Hello, everybody. I'm Michael Monaco.
And I'm Bobby Salveson, and we are the Hazmat Guys, bringing you the knowledge and insight to make your job a little bit easier.
Before we get into the show, let's thank today's sponsors.
HazSim training systems have been in use across North America since 2011. Hazmat teams, firefighters, confined space specialists, and industrial safety trainers alike have found the value in the HazSim Pro system. HazSim brings real information-based decision-making to students from instructors safely and realistically. No more burning up sensors or pretending a 3x5 card is a meter in training. Visit hazsim.com for realistic training solutions.
All right, we are back with another episode of the Hazmat Guys. I don't even know what number this is going to be because
643.
643. We're rolling right through these episodes. We are in a seedy motel with a good friend of ours, sitting around a bed, hanging out with Paul Rogers.
The illustrious Paul
Yes.
Rogers.
And benevolent.
Hey, gentlemen, how are you doing?
Yeah, it's
Paul,
just,
tell us a little about yourself.
Well, currently I'm a lieutenant with the New York City Fire Department. Sitting on a couple of NFPA standards, one for CPC, one that's in draft right now, which is dealing with energy storage systems, which is going to be all over. It's going to proliferate throughout the country, probably throughout the world, actually.
That's really what your major focus the past couple of years has been on, right? Is these energy storage?
Yeah, it started off with that. I deal with a lot of green energy, but that is the primary thing that I'm dealing with is these energy storage systems.
which, AKA for the listen, that's a battery.
That's a battery, right? Yeah. Energy storage system's a battery.
He's using lingo.
You know,
guys.
it's
I'll
It's
break
down
this
to
down.
the level of a fifth grader,
Yeah,
all right? We're talking
yeah.
about batteries here.
Well, yeah, right. It is. It is. It's a bunch of batteries.
All right, so
Why?
yeah, I mean, like when I think of batteries, I'm thinking like even new wave kind of stuff. It's like hybrid batteries, right? Where they're, like holy cow, these things are holding hundreds of calories, hundreds of volts. Are we talking like bigger, better, stronger? What are they?
Yeah. Usually they're measured in megawatts or kilowatts and things of that sort. So there's a lot of stored energy that's going out there. But batteries are everywhere. Whether they're in cars, right? Electric vehicles. They're in trains. They're in consumer products, whether it's your iPhone or your computer battery and stuff like that. They're in planes. Matter of fact, there was some incidents that happened in planes. If you remember Sully, right? Remember Sully? He came down on
the
the
guy
Hudson.
went in the Hudson.
He lost his both engines, right? How do you think he brought the plane down?
Gravity.
Gravity is one
That
way.
definitely helped,
Put in a smooth landing.
right?
No, the batteries, the backup battery system, actually, had the rudders. He was able to move the rudders with the backup energy storage system with batteries that was
I
in there.
guess that makes sense. Everything is done electronically now.
Yeah,
Well, what is it? The batteries ran the hydraulics to move those? Is that how it works?
that's exactly how it works. Yep, that's a
Interesting.
backup system in the event that something goes down, just like happened. Like if he needed to put the wheels down, the batteries would have actually put those wheels down too. It would have
Really?
taken over where the engines conked out.
Wow, I didn't know that.
Yeah.
That's pretty cool. So what were batteries years ago? What are they now? Why are we kind of starting to realize that they land within the realm of hazmat and firefighting? How is this all tying together? Like what has
Is
changed?
it the technologies come to fruition?
Yeah, it's funny. I think the lithium-ion batteries came out actually in the 70s, where they started to experiment with these things. And it didn't really start to take off till the 90s, and even later than that.
Well, in all fairness, they were experimenting with batteries and cocaine at the same time. So, you got to choose one or the other.
You can't push too hard.
That's right. That's
You
right.
blow out an O-ring on that.
But yeah, it's actually a new chemistry within the battery world. Years ago, they used the lead acid. Lead acid's been around for a long, long time.
Is that the wet cell?
Yes,
Like we
they call flooded lead acid.
Yeah, we used to pop the tops in the car batteries and pour water in it every once
Sulfuric
in a while.
acid and stuff like that. So it's inside of those things.
What do you mean that the chemistry has changed?
So like, we call it the chemistry. There's a flooded lead acid. There is a lithium-ion. There is these flow batteries. There's nickel cad that we've seen out there, the nickel metal hydride. So now the one that is probably the biggest bang for your buck or the most energy dense is these lithium-ion batteries. And they
Why?
last longer. There's no maintenance to them. There's no operating off gassing when they're actually operating. They're pretty much maintenance free, which is pretty cool. And they last longer than a lead acid battery would.
But why are they so potent? Is it the combination of metals, non-metals, and the real chemistry? Or, I mean, are they going to be able to tweak one ion? Or, you know what I'm saying? Like, are they going to be able to... Are we at the top? Are we at the pinnacle? The ceiling?
No, I'm sure there'll be something else coming out. Like, for instance, there's actually, now, I said lithium ion. There's actually lithium metal batteries, but they're very volatile.
Because
Right?
lithium itself is
There's a
really
difference between
badass.
elemental lithium batteries and lithium ion, which is more of a salt. It's not the lithium that we're thinking about.
So what's in my computer and my iPhone 7 that burnt
yeah,
a hole in my pocket?
that would be a lithium ion battery.
That was funny.
That was funny.
That was really good. When
that burned what?
burned a hole in his pocket. It was so funny. I was videotaping it.
Are you serious?
No.
I hope it is.
Oh, I thought you
that
guys were
hurts.
serious about
I
that.
hope it's so serious.
So what we commonly see in our cell phones, that's lithium ion.
Correct.
So where would we see a lithium metal battery? Or is it just kind of in the
On the drawing board?
on the drawing board stages?
I think the military may be doing experimenting with it. I don't think they're there yet with the fact that they're unsafe. They're not as safe as the lithium-ion batteries, but they're pretty dense energy from what I understand.
See, I remember-
I don't do much with the lithium, so I don't know a lot about them to get too much. Lithium-ion is one thing, but the lithium, I don't really deal with them because you don't see them much.
Okay.
So, and I don't think that we're going to see them much out there.
I remember, like, the first time I really paid attention to batteries probably was when I was getting into the fire department and into EMS and stuff like that, and the radios had them, and then I remember getting like DeWalt tools, and I'm not pumping DeWalt at all, but I'm saying DeWalt tools, they had batteries, and I remember like everybody's like, you got to charge these things once a day because they fade so quick, and now the newer batteries have much less fade. It's like you can charge them once a week.
Yeah, forever.
And they'll hold like 90% of their charge. Is this because we've gotten better at making... Is it the better chemistry or is it a better manufacturing process?
You mean as far as like a memory?
Like it holds the
Yeah,
power better
I'm not exactly
for
sure
longer?
what's the memory, but I'm not exactly sure why that's the case.
Okay.
Why they have less of a memory. now.
So what is it about the lithium ion that makes it seem so dangerous? Like,
So
what's going on here?
the lithium ion, depending on who the manufacturer is, who's putting the systems together, whether it's in a car, in a plane, a train, or actually in these energy storage systems for used on a utility scale to run buildings and such like that. It all depends on who is actually making them. There are some people that are very diligent, very conscientious about safety. For instance, one of the companies, I'll try not to really peg anyone, but they're concerned. They're very, very good about safety, extremely good about safety, and they're concerned about people who are not so good on safety, and they're going to be able to, have a problem out there, and it's going to look bad for the whole industry, the industry as a whole, and that brings everyone down. So they really want more testing of the batteries for each person or each manufacturer that makes them, because there's not a lot of testing out there. It costs a lot more money to do the testing. So this one company who has done a tremendous amount of testing because they want to make sure that their battery is safe, is holding everyone's feet to the fire. They said, do some testing on your batteries.
Why is testing so rare? Is it because there's really no standards yet? Is it because it's that new? I mean, it seems like batteries, they've been around for a long time.
Look,
why is this so...
There's a couple of things.
New.
Number one, it's expensive. Number two, what are you testing for?
Oh, there's no parameters, there's no metrics.
No. You have to say, when you do a test, it's like, all right, what are we going to test for? Or what type of, are we going to set it off by gas? What's the heat release of that gas is going to be? How long are we going to put it on there? Are we going to capture anything off it? What are we looking at when we do it? So a whole description has to be written up on what the testing is. Very precise. And you just don't do a testing for no reason at all. You do a testing to try to get information about the battery. All right, and how it's going to be used, what it's going to be, what's the application for it? Is it going to be in a car? Is it going to be a plane? Or is it going to be in a building? So all of that stuff is going to drive how the testing is done, if that makes sense.
Yeah.
And I guess you really wouldn't start testing something unless there was a problem, and the problems are
Or they
only
wanted to
just now
improve
starting
something, yeah.
to come about.
You know, the car manufacturers have done a lot of testing with it. They're pretty good, right? You don't hear many car fires, right, with lithium-ion batteries.
No
going
more
on.
than normal.
No.
If
So
that, probably a little
they've done
safer.
a lot. But their application is different than someone who's going to be putting them into a building.
Why? Like, what makes? I know that may sound like a stupid question. Like, you're like, what do you mean? Why? Like,
I would say probably off the
But
layman's
size
thing. I would,
would be the
I
only
would
thing.
say the compactness and the ventilation. In a car, you get a constant wash of cool air, and in a building, they're typically put in a room, a closet, with zero vent.
See, but now I was thinking that it would be the massive amount of energy in a small area for like a big building.
Well, look, in a car, right? You open the door, you're outside the car. In a building,
It's true. It's a good
right?
point.
In a building, you got all these people that may be above you, all right? There's no standard out there to say where they got to be put. Can you put them on the 30th floor? I don't know. It doesn't say anything in the standard because there is no standard. Can they be put in a basement? Can they be put on a rooftop? Where do you put these things? But a lot
So
of
that's
people,
what we're going to find out.
well, that's what we're working on now within this NFPA 855 standard, all right? We're giving some sort of guidance to authority having jurisdictions, the one who actually have to accept these batteries into buildings, like buildings departments, fire departments, environmental people in localities. So they have some sort of insight on how to do this properly. Because there is, if you just put these things in there and say, well, I hope everything works out, you're really not you're doing a disservice to the people that you're working for.
Well,
You're one of the people writing this new standard, right?
I'm on the committee on writing the standard. Yeah,
and it's called the Paul Rogers Standard.
it's called right. NFPA 855 Paul Rogers standard.
That would be great
You've heard of it?
if we could get that to catch on.
Yeah, you know what? I'm going to Photoshop that anyway. So
That's great.
What kinds of things? What would be the best way to describe this? So the standard includes pretty much anything that has to do with a battery in something, or are you just looking at buildings? Or are you looking on how it's connected to the grid? Like what goes into the thought process of what is considered important enough to be in a standard? I know I got a lot of questions.
this standard's got to be huge.
It's got to be tremendous.
This
Bigger than any other standard.
This
of course.
standard is very, very, the scope of it is lithium-ion batteries, or what they call stationary lithium-ion batteries, things that cannot move, right? And they even got a threshold at what number we want to start at. So if you had something that was maybe half a kilowatt, well, guess what? This standard's not going to cover that, right? But when you start moving up in the amount of energy being stored, then the standard kicks in and says, all right, if you're going to have this threshold, or you're going to go above this threshold, then you're going to have to, if it's going indoors, you're going to have to use certain sprinkler systems or spray nozzles, or you may have to get some testing done by a, what they call a NERDL, which is a nationally recognized laboratory.
What did you call it?
It's called a NERDL. That's just
A nerdle.
NERDL.
Like a small spot with nerds.
Right. That's just the industry
Indeed.
term. So it's called a NERDL, National Recognized
That's
Laboratory.
fantastic.
So, I mean, that leads me to my next question.
National Recognized Testing Laboratory. That's what it is. NERDL.
So, what does this mean to first responders?
So when I started this project about 3.5 years ago, I was reading through some of the SDSs on these things, and they were all over the place. You had one that said, use the appropriate extinguishing for the firefighting measures in the SDS, right, the safety data sheet. One that says, use the appropriate extinguishing for this particular battery. Well, what is that? Other ones that said use foam. Other ones that said use like a Metal X or a Lith-X.
Like a dry powder.
Right. Other ones who are saying
Run.
use, do not use water. With the water across.
The reactive.
So they were all over, and we had a meeting up at the NFPA up in Quincy, Massachusetts, and we sat down with someone and we said, "You guys have the exact same chemistry. You're saying use this. You're saying not use that. Like you guys were all over the place. How can you have the same chemistry using all these different extinguishing agents?" So they had to think about it.
What was their answer? Were they just like,
they agreed.
We used an 8-ball and that's what popped up?
They agreed.
Did they have an
That's
answer?
the problem, Mike, is they haven't done their due diligence. They haven't done their testing. And it shows. It shows they haven't really, they don't know their batteries that well. They know how they work, but like a lot of people that come into New York City, right, where I'm a lieutenant, into the fire prevention, first question, like, well, what happens if these batteries go on fire? They'll say, well, our batteries don't go on fire. So we kind of say, well, we know that there are some batteries like this that do go on fire. And then they're like, well, ours really don't. So what do you do in that situation?
Right.
You kind of want to just throw them out
Call
of the
the guy
office
a
and say,
liar.
all right. No, you don't want to call them a liar. You just say, well, you better go back and
back to
take a
the
look at
drawing
that
board.
again. So.
Now, is that just because they don't want to admit their battery goes on fire, or do they legitimately...
I have to say, anyone within New York City, anyone that comes in, I don't think they're not trying to lie. They're really not. I truly don't think that they know.
Are they salespersoning you? Like, oh, our stuff's the best.
Well, you know what? There's so many different safety features on it that they think that it's impossible for it to ever happen. Like if, for instance, if it's overheating, it will shut down the charging mechanism.
Yeah, we've gone to, probably in the last 2 months, we've gone to, a couple of battery issues where these things are stacked up like little motorcycle batteries all barred together, and we had a corrosive atmosphere, and in basements of major buildings.
Well, yeah, as I said, you're going to see them all over the place. You're going to see them in private dwellings. You're going to see them in apartments, not apartment buildings, apartments, individual apartments.
Why? What's the driving force
you
behind that?
You can go into the electric company and say you want to be on the special program where you pay X amount. If you use the energy at night, they give you an incentive, and you don't. If you use it during the day, it's a tremendous. You pay an extra amount of money. So what the people are going to do is they're going to charge this battery at night.
When it's cheap.
Store it, and then if they got to use it from the day, they grab it from the energy storage system, and they'll run their items off the energy storage system. Kind of makes sense, right?
Yeah.
So other than electricity, what are the hazards coming off of these batteries? I mean, I know there's a ton of different chemistries, and you can't go into every hazard of every different chemistry, but when you envision these bigger units in buildings and you envision these smaller units in apartments, how do you, what are the hazards associated with that from, forget a firefighting point of view, let's talk about a hazmat point of view. What could they be given off? What if they're broken open? What if something spills out of them? What if they start leaking?
Well, there's a couple of hazards. Number one, when they overheat, they'll vaporize the electrolyte. The electrolyte would be the corrosive that's inside of it, all right? And when that vaporizes, it's a flammable gas. It's a cocktail of flammable gases. And they're still uncertain on what that cocktail is made of. All right. We know that there's hydrogen in there. Hydrogen really nasty. But again, it all comes down to how hot it gets. So you may have a certain release at one time and not have that certain release at the other time. So it's a very hard thing to pin down. That's why testing is so hard. And I know guys who have done great testing on these things, and the test results are all over the map. So the repeatability of the test is very, very hard to do.
So, I mean, like, if you have these, let's say it's in a building or in an apartment, and I have, one or two of them, I'm gonna guess that if I had them packed tightly and the ventilation fan breaks, something like that can cause a thermal feedback loop, right, where things just start running away. right?
Once there's these things in there, in some of the batteries, all right, there's these things called a BMS, a battery monitoring system. So it recognizes when there's a problem, and it should be able to shut that thing down.
What do you mean shut it down? Like
Shut it down
open
as
a
far as like
fuse
the charging. The
or
charging
switch?
mechanism should just say, all right, you know what? I'm not giving any more energy into this thing because
And now it's a discharge only mode.
It may be just a stranded. It may have just be stranded energy where it's not going in, it's not going out. They basically just cut everything off. They cut the fuse to it or whatever.
Okay.
Just kind of becomes a capacitor, just holds the energy.
Yeah, it just holds that energy in there. All right,
Now,
so that energy is now stored. They call it stranded energy, where it's not going in and not going out.
Is there a size for that? Like, does my computer have a automatic shutdown, or are we talking about like?
Did you ever put your phone in the sun?
Yes.
Yes.
What happens?
It stops charging.
Exactly.
So it's
So
doing
it's
the
got its
same
own
thing on a
BMS in
smaller.
there. Yeah, it's got its own BMS. But if you don't take it out of the heat, that BMS is not going to do anything for you. It can actually set that thing off. So just because it stops charging doesn't mean it's going to get rid of the heat. Maybe an external source.
Is this an electronic switch or a mechanical switch or?
It's an electronic switch, and I don't know a lot about the BMS.
Only because I'm thinking about failure.
It's the eyes and ears of the system, of the batteries itself. So basically, it regulates everything within the battery. It tells the state of charge, the state of health, the temperature of the thing, how much, what's the lifespan of it. So it does a lot more than what I'm mentioning there. There's probably 50 things that it actually looks into. Voltages,
Wow.
Overcharging, undercharging. Believe it or not, even undercharging can set these things off. If you undercharge it to a point, you can actually have a thermal runaway event.
Are the military looking into this? I mean, I'm sure in some way, shape, or form they're pushing into this stuff. I mean, this field has to be.
Yeah, the military's looking into it.
Rails by Spectral Labs is a computer-based training game for first responders, hazmat teams, law enforcement, anybody that uses CBR&E equipment. Pretty much anybody that listens to this podcast. You can practice in realistic and hazardous scenarios that are difficult to simulate in training exercises. Things like an underground gas leak or a highway chemical spill, or even locating and identifying a high-activity radiation source. The best part? It's free. It's free to federal, state, and local agencies. So just email or call Spectral Labs and let them know the name of your agency and the hazmat instruments you use, and they'll take care of the rest. The email is training@spectrallabs.com, or the phone number is 858-207-3727, and then press 1 for the Rails team.
And it makes sense to use them because they have such a long lifespan. And they're so much, energy dense, right? You can store a lot of energy
In a small spot.
in a small location.
I heard that's kind of what made them so unstable, is that there is so much energy in such a little space that
Couldn't cool?
that energy can just release so quickly that you can basically pop the battery. Is that?
Yep. You can you can fail the cell,
Okay.
right? You actually can fail a cell, and that energy storage systems, those big ones, utility size, they can continue to run without any problem at all. So you can have a failure in that cell, release its electrolyte, could set off the smoke alarm. You guys show up to the scene, you see nothing but a big line of batteries and see nothing there. And that's my biggest concern is all right, now what? Is there something going on or not? So that's why I've been working with the manufacturers to try to get them to give us information off that BMS. So the fire department can show up and take a look at the BMS monitoring as far as temperature is concerned.
Can
And
that be
take a
done
look at
remotely? Can a central office, let's say in Memphis, watch its buildings in New York City?
So, 855, that standard I mentioned before, all right, on this is for energy storage system or stationary. I don't want to say they're going to be on cars and everything like that.
Right.
For the stationary systems that are going to be inside buildings or even outside buildings. One of the things that I asked for is that this BMS data will be available to the first responder, whether it's going to be at the scene or through an emergency telephone number, that first responder can call up and ask, is there any problem with that? It's a very intricate thing. I try to boil it down for the first responders so they wouldn't be intimidated by it. And they would be able to say, what is the trending temperature? So you can get a temperature, right? Just say it's 100 degrees. Well, that's fine. but is it trending up or is it trending down?
Right.
And if you have it trending up, then that's not a good thing. And you may need to stay there or call someone from the company, a subject matter expert in some situations, to come here and babysit that, because they could have very long delayed ignitions. Even just by shutting them down, you could shut these things down, emergency shut off. That doesn't take it away. That doesn't take the problem away.
That's kind of like the solar power, where
you got
firemen go up on a roof and they
think they're cutting the
I
power,
cut the power, I hit the switch, but meanwhile the things are still producing electricity in there.
And that you're going to see that a lot. Whenever you see it from now on, when you see a solar system, a solar PV or solar on the roof in a private dwelling, the new ones are going to be hooked up into energy storage for sustainability. So not only are you going to shut down the PV system, but you need to shut down the battery system too. So you got to shut down both of them. And we're trying to line them up. See, that's what I'm saying. So many things have come into this energy storage thing that we had to look at so many different things. Like even the fact that now, one of the things that I was privy to was one company wants to put these batteries in the back of a truck and then utilize them at certain places when they're having a power failure. So this way it can help.
Like a tractor-trailer kind of thing.
A tractor-trailer. Now, is that considered energy storage, stationary energy storage? Or is that mobile? How do you treat that thing?
Well,
Meanwhile,
I'm no expert, but it seems pretty mobile.
It seems mobile, but you got like a 1.5 megawatt of power sitting on a street with no engineering controls around it. Right.
Right.
Wow.
Right. So these are all the things that we're looking at, and it got very lengthy on all the different options that are out there with these energy storage systems. You'll see them everywhere.
So I want to get back a little to the actual technician getting off the rig. I pull up to the scene.
The hazmat technician.
The hazmat technician, yeah. So I pull up to the scene. There's been some kind of an alarm going off. We're being told it's coming from the battery units. I don't know a whole hell of a lot about what's going on in there. I'm getting off the rig. What PPE am I grabbing? What meters am I grabbing? What am I looking for?
So when you approach the room, we're going to have signage there to let you know that you have an energy storage system. All right. And there's a couple of different applications within the energy storage system: UPS, emergency, peak shaving, load shifting. So all that stuff is also incorporated.
All different batteries, all different technologies?
Yeah, you're going to handle them a little bit differently when they're not on fire. When they're on fire, we're pretty much handling them all the same way.
Okay.
But when they're not on fire, you may handle them a little bit differently. Like, you may not shut off a UPS system that's not on fire.
What's UPS?
UPS is a uninterrupted power supply.
Okay.
So a lot of these places, like for instance in Wall Street, New York City, they have their data backup hooked up to these uninterrupted power supplies. Let's say the grid goes down. The batteries instantaneously pick up that power until the generator kicks on. You know, the generator doesn't kick on the moment that the grid goes down.
It takes a while to warm up.
Right, it takes some time, and then there's a ramp up speed and everything like that.
Okay.
So these batteries will just hold that power till that generator is up and running fully, that it can now shift the load from the batteries to the generator.
So what kind of hazards would be in there? Like, I'm going in there with my PID, my 5-star, maybe some pH paper. What could I expect to see walking into this room?
You mean for lithium-ion, right? You want to be specific to lithium-ion?
Whichever you think I'm going to.
Well, the biggest one that's going to be out there is lithium-ion.
Okay, so
that's the one that is going to start to dominate. Right now, the biggest one out there is the lead acid, which are pretty stable. You probably haven't been to too many calls on that.
I think we've been to one or two where the acid has broken into the room.
Yeah, they're pretty stable, plus the fact that those things are, again, being on the UPS fashion, they're always in a state of charge. They're not cycling back and forth each day, so there's no wear and tear on the batteries. They're always kind of in a 100% state of charge.
Okay.
So we don't see that cycling go back. When you get into peak demand or load shifting, that's something that's going to be cycling every single day.
Okay.
Back and forth, back and forth, back and forth. So lithium-ion would be the obvious choice because space in a building's expensive. So if you can reduce that space by 1/3 of what a a lead acid battery would take up and have the same amount of energy density, you're going to go with lithium-ion. Plus, there's no maintenance to it. It lasts longer, and you have the energy density. So it's kind of a no-brainer for everyone to do.
Okay, so I'm walking into a room that has the lithium-ion batteries. I've got my normal complement of meters that I have. Paul's a hazmat technician, a specialist from way back when, so he knows exactly what I'm talking about. So what would I expect to see going into it?
So going in, you're going to go in bunker year, right? Because flammability is going to be our biggest concern.
Okay, because of the tox being given off from the battery.
Because of these vapor, that cocktail that I mentioned before. Right?
Okay.
Because of that cocktail is very flammable. And what we've put in the standard is it got to be below 25% of the LEL for the room itself before these ventilation fans stick on. So we want access for the incident commander to have an on and off switch for the ventilation fans, just in case something overrides.
Why not just have them on and leave them on? What would be the benefit to shutting them down?
When there's a difference between normal ventilation and then basically almost like a purge.
Okay.
Like when these things off gas, they off gas so quickly that we're hoping that the fans will be able to handle the off gassing.
Really?
Yeah. So it's a purge. It's kind of like it's sucking that stuff out immediately. But if you ever saw a battery when it does go into this what they call thermal runaway, right, event where it has all this electrolyte coming out, the rate at which it comes out is pretty significant. So, and if you multiply it by numerous cells going off at the same time, it's really significant. Or if you get into modules, then it's even more significant. So to try to get a fan that's going to be able to exhaust all of that smoke, we'll call it smoke or vapors, is very, very difficult.
So you're almost
you have to figure out the CFMs. There's so much involved in it.
Ventilate the whole room all at once. That's really what you're trying to do.
That's the goal.
Change out
it's
the air.
Actually, believe it or not, from my point of view, I'd rather them be on fire. So it's consuming that stuff. Because if that stuff finds an ignition source, you could have a deflagration. Maybe even a detonation. You have a detonation inside a building. You know, some of these buildings, depending on what type of wall it is or what type of hazard, is it going to be a high hazard or is it going to be just an ordinary hazard? You know, ordinary hazard building, right? The walls, maybe 5/8 sheetrock, 2x4s. Anywhere from a half PSI to 1 PSI on that wall will take it down. If these things explode, you're going to be much higher than that.
Now, is that, just to be clear, is that the battery exploding or is that the room filling up with
That's the gas.
The gas and the gas exploding?
The gas is exploding.
Now, a battery's involved in an explosion like that. Is there going to be more release and then more explosion? Or once it's kind of the first explosion's over, it's really not going to explode anymore?
I don't know. I don't think that's the case. I mean, when they explode, they could that does not necessarily going to mean the fire's going to go out.
Okay.
It's just going to be, hey, you got this one chunk of gas that reaches its LEL, or now I think they call it the LFL. There's a difference between LEL and LFL, which I
Never
didn't
heard
realize
of
that.
What is it? LFL?
Lower flammable limit versus the lower explosive limit. There's actually a scientific difference on it. I didn't know that, but they kind of explained this to me too. And I know I heard some guy was telling me that hydrogen has an LEL of 4%, but it really won't go up until it's about 8 or 9%. Now, don't hold me to that. This is what he said to me. I'm like, how can that be? I didn't understand it. I got a little more investigation on that. But,
Okay.
But supposedly there is a difference between that. And
so the room, let's say the room hasn't exploded. I walk in. What am I going to see on a 5 gas, a normal 5 gas with your standard confined space gases?
Well, it depends on what your gas, the calibration gas, right?
Okay.
Remember, it's a cocktail. It's not one specific gas, so there's not going to be any correction factors for stuff. So you may get a reading on your LEL meter.
Okay.
You probably will with the rate that it's coming out. You're definitely going to get readings on it.
PID, any of these things below 10.6?
I'm not worried about the PID stuff. I'm more worried about the flammable gases.
Flammable gases.
Yeah, there's going to be toxic gases. They automatically assume there'll be toxic gases. Don't even worry about that. Mask up. You should be
And you're
with that.
comfortable with the structural firefighting gear and an SCBA with the toxic gas mix?
I'm comfortable what?
Wearing structural firefighting gear, bunker gear, and a face piece, walking into these rooms with the toxic gases?
Yeah.
Why? Why that versus like going in a B?
Because the gases that are emit as far as toxicity is concerned are very similar to a structure fire.
Okay.
Or
But-
transformer fire,
Yeah.
right? Electrical fire-ish.
And you know, and you know, it varies though, Mike. It varies on what type of chemistry within the lithium-ion family you're at. For instance, if you're a cobalt oxide, maybe a little bit different than a nickel magnesium cobalt or a iron phosphate, a lithium iron phosphate, and all of them will change the dynamic of what the smoke is and what's inside the smoke.
All right, give me the short term and give me the long term of where batteries are going. Where is this technology, this stored energy systems going? Where do you see it?
This is very, very. It's a common sense thing to do. It's kind of a no-brainer for any utility company to do it. It's going to help them with their infrastructure to maintain it. So it's a no-brainer. This will proliferate throughout the United States very, very quickly. They are waiting for this standard to come out. Once the standard gives guidance, authority having jurisdictions will be allowing these things going in just by looking at what the standard we wrote. That standard is looking to hold the manufacturer's feet to the fire about testing their batteries. Prove your battery's safe. So that leads into another standard, which is a product standard called Underwriters Laboratory, or UL 9540. So UL usually does products, and NFPA usually does like building installations and stuff like that. So UL 9540 is the system product standard. So they would have to put their system on fire, or they call for large scale. Now, when we talk about large scale, right, 9540, what's considered a large scale? 10 megawatt, 1 megawatt, 500 kilowatt, 10 kilowatt, 20 kilowatt. So all of these things still have to be ironed out. Like, and then what are you testing them for? Well, let's just burn it and see what happens. No, let's test it and see if it explodes, what type of pressure's coming off that explosion. You know, should we put a wall there? What happens to the wall? How far does it need to be next to the adjoining cabinet, if they were in cabinets, or rack? Will that heat transfer over to the next one and set that off? So all of these questions are questions that we're looking into in the industry. And Underwriters Laboratory is looking to put that testing procedure together. They're coming to New York City to sit down with some of the people that we have working on these batteries, and they're asking some of our concerns, so we can address those concerns. So if any of your listeners have concerns about these particular things, you know, tell them to get in touch with me or whatever, or get in touch with you guys. And then maybe there would be something that we didn't think about that we can say, hey, you know what? Did you think about this, to test for this or test for that?
From a first responder's point of view, what do you feel is the biggest challenge? Because you're on the NFPA committee representing first responders, correct? Mm-hmm. So what do you feel is our biggest challenge facing this new world of batteries everywhere?
Our biggest challenge is the unknown.
The unknown.
Lack of information, the gap that's in the fire service about not knowing what to do. Meanwhile, these manufacturers having their SDS call the fire department if these things go on fire. And you guys, and most fire departments have no clue about it.
So it's like a bunch of people just pointing fingers at each other.
Yeah.
Going,
just, hey,
go that
call
way.
them.
Well, that's definitely something we're going to have to keep an eye on in the future. You know, to find out where we're going to go with that. But
yeah. How much time do you think it will be before we have tangible information to be able to make decisions off of?
So I was involved in putting a course together with the NFPA. So the NFPA got some grant money, and it's an online course. The problem with I like online courses. They're okay, but you don't have that interaction because you're just kind of reading something, but you can't go back and ask questions. So it's not a bad start, though. It can give you a general idea on how to handle these things. So even when we were writing it with a couple other guys, we were still saying, yeah, I'm pretty certain we're good with this. And I think we hit the mark. I think we're good on it. When you go through it, you'll see. The information's pretty good.
All right. Well, listen, tell where can we find that course? Where can we find you?
So if you go to the NFPA website, right, and then you put in ESS training.
ESS, like
yeah.
Edward
Yeah. E, Edward, Sam, Edward,
Like
Sam.
energy storage system?
Yep.
Okay.
Training. It should bring you to the link. And then it's a, 3-4 hour course online.
That's easy. I could do that in a half hour.
Yeah.
Yeah, you can do the half hour.
May take me
Only
6
smart
hours.
guys. Yeah, and when you get to the meat and potatoes, you'll see. But some of it kind of goes into like just the principles of electricity.
Yeah.
Like some people don't even know the principles of
Fundamentals.
electricity, the fundamentals, which is good. It's nice to know.
Where can we find you?
You can get in touch with me either through you guys, right?
Absolutely.
Yeah, sure.
Anytime
Hazmat
anyone
Guys,
wants to get a hold of you, you can go through
can,
us.
You can get in touch with me on LinkedIn.
LinkedIn. What's your profile? Listen, it's a G-rated show. You got to give the good one. Right.
I think it's Paul Rogers.
Paul Rogers, spelled normally.
right, R-O-G-E-R-S.
Well, I got to say thank you very much for sitting down with us for a little while tonight. I know we kept you up late. It's 7:30 in the p.m.
Yeah, it's about an hour and a half past his normal
Yeah.
bedtime. He is literally, his eyes are closing.
Closing.
And
He's like,
he's rubbing his face right now, trying to stay awake just long enough to be able to make it to the next hotel room so we can crash out.
Well, thanks a lot.
All right,
appreciate
guys.
Well, that wraps up another episode of the Hazmat Guys.
You can find us on Facebook, Twitter, and our YouTube channel at The Hazmat Guys. And take a moment to call our comment hotline at 843-628-1484.
We are always looking forward to your feedback about information or interesting incidents that you are part of. So send us a note at feedback@thehazmatguys.com.
And remember, guys, don't just get on the job. Get into the job.